This is a run-through of the answers for your weighted assessment in Term 1. For question 1, it tells us that air is pumped out of the jar and that we can recognize that the sound becomes fainter and no longer heard. So what are some things that you know about sound? We know that sound is something that is able to travel through a medium when there's vibration. So when I don't have air, I'm removing my medium. And without my medium, I can no longer have any sound. Or rather, sound does not travel anymore. So let's take a look at all the different options. Frequency decreases as the volume of air decreases. Is frequency and volume related? From what we know in the chapter, frequency is related to pitch. Amplitude relates to the volume. So this A cannot be correct. The bell stops vibrating when there's no air. Here's the thing, the bell can keep vibrating, but what we don't hear is a sound. It doesn't mean the bell stops. It's just that we cannot hear the sound anymore. The speed of sound decreases as air pressure decreases. Now, when we look at air pressure, we do know that we're talking about compressions and rarefactions. The speed of the sound doesn't have to do with anything with the air pressure in this sense. The most important thing to recognize is without my medium, I am no longer able to hear it. So this demonstrates sound waves requires a medium for transmission. Question 2 is pretty straightforward. Since sound requires the particles to vibrate and then sets up a series of compression and rarefactions, the closer the particles are together, the faster sound will travel, right? So it is common knowledge that it's fastest in solids, slowest in gases. Some of you all mistook it and you all went fastest as gas and slowest as solids. No, so it's fastest solids, then liquids, then gas. Number 3, what's the use of gamma rays? If you couldn't do this one, you probably did not revise concerning the usage of the different things in EM spectrum. So based on what we have inside our syllabus, broadcasting satellite television signals would have to be microwaves. Detecting forged notes would have to be ultraviolet. Operating a television remote control would have to be infrared. And that leaves us radiotherapy treatment as gamma rays. So that's how you do the first 3 questions. Question number 4 is a reflection question because it's a mirror, and we always remember that if I need to talk about reflection, I must always remember that one thing I must do is to draw my normal. Now, once I draw my normal, I must also remember that the angle which I'm concerned with is between the ray and the normal which I drew, which means this 57 degrees is not the important one. I need to consider what is over this. What's over this? What's this? So 90 minus 57, that gives you 33 degrees. So they asked me what's the angle of reflection. They're not asking me for the whole thing over here. They're just asking me for this angle right here. So the answer has to be 33 degrees. Finally, our diagram. The diagram shows a ray of light moving from a sapphire mineral into air. So what's the refractive index of sapphire? In our textbook, we have 2 formulas for this. N equals to sine I over sine R, right? Where N tells me the refractive index, I is angle of incidence, R is angle of refraction. But the textbook also says that if it's going from more optically dense to less optically dense, then the formula becomes sine R over sine I. So in this case, we need to use this version of the formula. That will bring us to N equals to sine 62, which is the bigger angle, over sine 30, which is a smaller angle over here. And for that, you will get the answer about 1.77. That gives us C. So that is the first 5 questions of your WA. Question number 6 is a sound question which looks rather complicated, but once you understand the trick behind the question, it becomes quite straightforward actually. So we know that there's a boy standing over here, and behind there's a girl 200 meters away. Now he's going to clap his hands, right? So we know that between the 2 claps is a time of 0.9 seconds, right? So what happens between the first clap and the second clap, right? So let's try to understand it. One way of thinking about it, which is the longer way, is that I know that sound will travel from here to here, correct? Now that's going to be the echo, but the first clap actually comes from here. Can you see that? So after this sound wave travels here, it takes another 0.9 seconds to hear the sound wave continue to travel here this way. So it looks something like this. The sound waves will travel here like this. They travel, boing, and 0.9 seconds for it to travel this way. So what really is the difference between the black and the blue line? If you can see, the difference between the black and the blue line was actually covering this distance over here, isn't it? Which means this distance required 0.9 seconds. And that becomes a very, very basic echo question, isn't it? So how do I solve it? If I can understand that this distance took 0.9 seconds and asking me what is then from here to here, I can do this. It tells me that this over here is D, the distance between me and the wall. And just as we know in echoes, the total distance to travel this way, distance is speed times time, correct? So it's equals to the speed over here multiplied by the time taken to travel from here to here. So what is the distance? So D is equals to divided by 2, and you're going to get your answer 148.5 meters. Done. Question number 7 again is on sound. So let's take a closer look. We know that this graph over here shows the sound from cats. This is sound from dogs. Question number 1 asks us, question 8 asks us, mark a center of compression. Now, we do know that compression simply means the area where the air pressure is higher than usual, right? So if you were to look at mark a center on 7b, right? Mark a center of compression with an X. We know, yes, everything over here, these are all compressions, correct? Because it's higher pressure. If this is the normal air pressure, all of this is higher pressure, but I want the center of the compression. As such, there's only 2 possible answers, one here and one there, either or. If you put it anywhere else, it is part of the compression but not the center of the compression. The center is only here or there, right? So that's where many people lost marks. Determine the frequency of sound produced by cat. So I need to focus on cat. Where is cat? Cat is not 7b. Cat is 7a. So let's look at how we see this. Okay, of course the quality is a bit different. We don't see very, very nice sine waves, but we can see that this is one cycle, this is another cycle. So let's zoom in over here. I take note that this is pressure and time. So from this, I can find period. So what's the period of one complete cycle? Time taken for one complete cycle was 2. Something that you may have missed out is that we're measuring in milliseconds. As such, I will use the formula frequency is equals to 1 over period, except that my period is 2 times 10 to the power of negative 3 milliseconds. This gives us 500 hertz. So where people missed out was the millisecond part, right? If you could recognize that this is a period, that's good. Next time also check at the side over here whether or not I'm measuring in milliseconds or in seconds. Finally, explain which animal produces a louder call. So here we're focusing on this part, louder. As you said before, louder means I'm considering my amplitude. So let's check which one has a larger amplitude, right? Looking at this, for a cat, from here to the greatest displacement will be here, right? That's the pressure. But for the dog, it's all the way up here, which means the dog is louder. Why is the dog louder? It's because this sound has a higher amplitude. So that's how I get you 2 marks. First, tell me it's a dog. Secondly, tells me it's a higher amplitude. Question 8 is a typical EM spectrum question where you are able to list out the entire EM spectrum in the correct order. So gamma, this would be X-ray, this would be ultraviolet, visible light, infrared, this would be microwaves, and this would be radio waves. Our marking point is as such. If you get all 4 correct, you get your 2 marks. If you only get 2 correct, we give you that 1 mark, right? So it's either you get 2 right or you get all right. State 2 characteristics of radioelectric waves. There are actually about 4, right? So first, there are transverse waves. That's 1. Okay. 2, they all travel at the same speed in vacuum. And to be very, very, very specific, is in vacuum. They travel at the speed of 10 to the power of negative 3 times 10 to the power of 8. They also transfer energy, and I think those are the big 3. The 4th one would be things like the frequency doesn't change as it moves from one medium to another, right? But the easiest 3 are these. Alright, now we go to the part where we're looking at ionization and the hazards of ionization, which comes with the overexposure of it. So, describe one danger associated with prolonged and overexposure to the X-rays. In this case, we should not be talking about heating, right? An effect of overexposure is heating, but the danger would be cell death and cell mutation. Now, there's many other possible answers like cancer, organ failure, death. But I think based on your syllabus, the big 2 would be cell death and cell mutation. So either or. Now, this question is a bit harder to answer. It requires you to use a bit of logic. So explain why we still use X-rays even though there's a danger of overexposure. So this is really about a risk-benefit analysis where you have to say something similar to that. So one answer is that the risk of disease is greater than the risk of overexposure, or the benefit of a diagnosis outweighs the risk of exposure. Anything similar to that will give you the mark for your answer. Something like that. Alright, next question. This question is concerning refraction from the chapter of light. So we have these 2 light rays, and we're supposed to complete this diagram to show 2 light rays exiting the glass prism. So let's take a look at this one over here. We know something about refraction, which is it happens when it goes from one medium to another medium of different optical densities, glass air, but also has to be at an angle. But here at 90 degrees, right, there is no angle of incidence, which means there is no refraction. That's to say that this over here should continue to go straight without bending at all. So as long as you draw the line continuing, in this case, which I would label for A, right, you get a mark for no deviation, right? Please excuse whether this is thicker or thinner. This is just how the iPad is working. Now, what about this ray over here? This is going from a less dense to a more dense. If I were to use my normal just to help me out to see what's happening over here, I remember that as it goes into a more dense medium, more optically dense medium, this would be a ray that bends towards the normal, right? So something like this, right? Now, just by drawing this, I have not completed my question because I need to show it exiting the glass prism. So if you stopped here, you don't get the mark yet. So where does it go after this? Once again, I should be drawing my normal at this side of the prism. So it looks something like this. And now because it is going from a more dense, optically dense medium to less optically dense medium, I know the light is going to speed up. It's going to bend away from the normal. So I'm going to draw something that looks like this. Away from the normal. Let's try again. Something like that. Right? So this would be your light ray exiting the prism. So this is supposed to show us whether or not you understand where the light bends, when does it bend, and how much does it bend? Does it bend away or towards the normal? Right? Finally, calculate the refractive index of glass when I consider your speed. So now there are 2 formulas to remember. One is something that looks like this, where we use angles, but there's another one where we use the speed. This formula says that refractive index is the speed of light in vacuum over the speed inside my medium. So this would be the speed of light. So in this formula, right, the one that goes on top here is always going to be 3 times 10 to the power of 8. And this over here is the speed inside your medium. So when you use this formula, you got to answer 1.43. Finally, what is meant by focal length? We know that focal length is between here to here, correct? That's the answer, but how do we say it properly? So the correct way of saying is that what's here and there, this point is called the optical center, and this point is called the principal focal point, or principal focus point, right? Yes, we know there's a focal plane and there's many focal points on that focal plane, but we want this one over here, and this part, which is on my principal axis, this is called my principal focal point. So the distance between the optical center and the principal focal point is 10 cm. That's what it means by this. So you need to tell me that this is 10 cm. Secondly, using this, state two characteristics of the image. This is my object, this is my image. Very easily compare these two. Is my image bigger or smaller than my object? Well, smaller, so we use the word diminished. Secondly, this is pointing upwards, this is pointing downwards. Is it upright or inverted? My image is inverted. Finally, are the light rays actually meeting? We can see the light rays actually meet at this point, which means that this image is a real image. As such, you just need to give me two of them, which are diminished, inverted, and real. So just state two. Finally, suggest an application for the setup. Now, we do recognize that this object is rather close to 2F. It's not far away. That means we cannot say that this is a telescope. Telescope is when my object is at infinity, and then after I look into my lens and I see a small image. It's rather close by, so I cannot say that this is a telescope. The only two things that we could say, easily remember, would be it's either a camera or that's your eye. Right? So these are the answers for this. With that, I think we are done.